Dependence of critical mass in fission. As I have told you about the critical mass of the different fissionable materials, and which of them have some have the less mass, some have the higher mass. So this critical mass is the minimum mass, as I told you earlier, that if the mass is less than the critical mass, then there will be no chain reaction at all. If the mass is equivalent to the critical mass, then the chain reaction will take place without any loss or the damage. And if mass is more than the critical mass, then the big explosion takes place, and this is the uncontrolled chain reaction. So all the atomic bombs are based on this concept. So now here I will tell you that what factors affect the critical mass, or the critical mass depends upon which of the factors. So now let us have the first factor is type of fissionable material. So now we know that the fissionable material are different one, the uranium, plutonium, etc. There are so many these substances which go under this critical chain reaction, undergo this chain reaction. So critical mass is different for different fissionable material. Like now if we take the uranium 235, then the mass is equal to 52 kg. If we take the plutonium 239, then this mass is equal to 10 kg, etc. So now for different material the critical mass is different. This is the first factor upon which the critical mass depends. Now second factor. Temperature. In case of temperature, if the temperature is increased of the fissionable material, then what will happen? Because of the thermal energy, the energy of the neutron will increase. So these neutrons will not strike with the fissionable nuclei, and as a result they will leak out. So as the temperature is increased, the critical mass that also there will be no chain reaction at all. If temperature of fissionable material is increased, the energy of striking neutron will increase. And as a result the neutron will go out without producing the fission. It means that in that case we need some more mass. So the critical mass is at a particular temperature. This is not at all temperatures. The fissionable material has critical mass at a particular temperature. So we can say that when the temperature of the fissionable material is increased, then we have to increase the critical mass. Thus, a large mass is required for sustained chain reaction. Sustained chain reaction if temperature is increased. This is why that these fissionable material are kept at a particular temperature. So this is the second factor that affect the critical mass. Third, shape and size of material. This is the third factor. It means that if there is the fissionable material, then what should be its shape and what should be its size? Whether this should be taken in the cylindrical shape or should be taken in the spherical shape. What should be there? So that we have to select the shape and size of the material. critical mass is minimum mass required for sustained chain reaction. And we know that the sphere has the minimum surface area, so it has the minimum mass. It means that the shape and size of the spherical material should be in the spherical size. The sphere has minimum area, so the shape and size of fissionable material is spherical. This is why that spherical shape is required. All the materials are kept in the spherical shape. So this is the third factor upon which this critical mass depends. Now number 4. Composition, density and purity of material. All these elements are found in the nature, and some are so we have to find that how much they are pure, because impure material cannot undergo the nuclear fission. The incident neutron will be absorbed by this, so they will not cause any kind of the fission. Moreover, if we suppose the uranium-235, then this is found in the very less amount in comparison to the uranium-238. So this is very necessary to separate the uranium-235 from uranium-238, but this separation is very typical. So pure uranium-235 or the plutonium-239 is very typical process in the pure form. So this is why that the impurity also affects the critical size, the critical mass. Impure material cannot undergo sustained chain reaction due to absorption of striking neutron. So if it is absorbed, then this will not be the uranium-238 that if they are present in the uranium-235, then this neutron will be absorbed by uranium-238. So it will not cause any kind of the nuclear fission. It means that the composition and the density, higher the density, the low will be the mass of the material. So that also depends upon this density also. So these factors which have the composition, density and the purity of the material, they also affect the critical mass of the size. If density is increased, that you can see that in case of uranium-235 and the plutonium-240, the mass is large. It means that a large mass is required when the density of the material is low. But when this is large one, then the density is large, then a small critical mass is there. So these are some of the factors which affect the critical mass of the material. So sometimes this is asked that which of the factors, or suppose the multiple choice question, this is given that which factor is which option is true for the sustained chain reaction or the critical mass for the of the material, then we can answer all these from these factors. So thank you very much.